Okay, so we don't have the title that's there. Hold on a second. Um, we are in lesson number 5, systems of linear equations in two variables. Okay, so linear inequalities. We saw linear equalities yesterday. All right, graph the line just like normal, uh, dotted line. What side do we shade on? All right. And now though we've got systems, so that means we've got two of them. So, just like before, we when it was systems of equations, remember the equal sign? All right, we would just graph them and find exactly where they cross at. The point that they cross at was our answer. Well, now we've got a whole shading going on. So it's actually the overlap of the shading that gets it done. So yeah, let's go through here. So we have to graph them, of course, here. So we do need to get them in slope-intercept form first. Okay, so yeah, let's subtract our 2x over. So I've got a y less than or equal to negative 2x plus 3. We're done there. All right, the other one. Okay, I'm going to add my 6 over. All right, so I've got a 2y is greater than 6x plus 6, because again, we added the 6 over, right. Okay, and then, all right, well, y, yeah, slope-intercept form. So we need to divide everyone by 2. Oh, how nice. All right, so y is greater than 3x plus 3. Okay. All right. So we're ready to graph. So I've got contestant number 1 here, and I've got contestant number 2 here. So let's go up to 3. 1, 2, 3. There's my dots. Slope of negative 2. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Remember, it's rise over run. All right. So I'm going to make it a fraction. Shaded. I'm sorry. I'm getting ahead of myself. Solid line. Man, that took a while to come out there because of the or equal to. So I'm going to. Oh, that's bad. Maybe you did better, hopefully. Okay, I have to erase. All right, yeah. Okay, let's try that again. Okay, that gets the job. Okay, so we're okay there. Shading wise, all right. We're going to test them out, although we're going to let you on a little bit of a secret here. All right. I can go ahead and test them out. I can plug in my 0 because I'm going to test out that order pair 0, 0. I can plug in my 0, negative 2 times 0. And again, we can go through the math and say, hey, is 0 less than or equal to 3? And you're like, yeah. Let me show you something here. Because we're in slope-intercept form, now it's only when you're in slope-intercept form you can do this. We have a less than symbol here, right? Less than or equal to. So would you say it's above it or below it if you're less than? Yeah, it's below it. Now I'm actually going to go color here. All right, I'm going to show you here in a second as to why. All right. So yeah, you can actually trust the symbol here. All right, less than. You can think of it as to the left of the line, or you can think of it as below the line because those are both less thans. But we can only trust the symbol for a slope-intercept form. Now again, if you don't like that, plug in your 0 for your x and your y, test it out, and you'll see you'll get a true statement. Wait, let's grab the next line. All right, I'm gonna go different color here. So that one looks fun. All right, I'll go up to 3, so same spot. All right, and now I got a slope of 3 over 1. So rise 3, 1, 2, 3, run 1, run 2, 3, run 1. That's there. I'm gonna go down 3, a negative 3 to the left 1. Still gives me a 3. It's a dotted, something like that. All right. Okay, it's a greater than symbol. All right. Now, this is where, for some people, it's kind of how do I interpret it when we talk about greater than. And this is where sometimes it's dangerous and you want to go back to the testing because sometimes you look at the line and you're like, wait a second, greater than I'm visioning this way, but then I'm also visioning that's above it. So I'm not a huge fan of just trusting the symbol here at the beginning. Now, as you start to develop some tendencies, I do want to let you know what's out there. I'm going to plug it in here. So 0 greater than 0 plus 3. Is 0 greater than 3? Remember, I'm testing out this point right here. Is 0? No, it's not. So it's actually going to be shading above it. All right, because we got to do the other side. So my answer is the overlap. All right, so where's my overlap at? I'm going to bust out back to the black ink here. My overlap is everything. So this is my official answer that's there. So some of you might want to break out the markers. Hey, go right ahead. It's a very visual thing. Again, I didn't shade my answer, and again, I have to do that double shade. I have to darken it in um, to show like, hey, this is where my answer is at. So again, one red, one green, not part of my answer. Where I had my red, my green, everything there. So if I grab anything in that answer, it's going to work for both of them. And that's the idea behind the systems of inequalities. There's lots of answers that work. In the equations, there was only one where they crossed that, just that one point. Whereas here, we've got lots of answers that work, but we have to make sure it works for both of them. Kind of like your and statements here. It's an overlap that you're looking at. All right. Let's find another good one that's here. You're already in slope-intercept form, so I'm not too interested. Oh, 3 of them. Okay. All right. Y is greater than negative 3x. Okay. So my slope, my intercept right there at 0. Negative 3, down 3 to the right 1, down 3 to the right 1. All right. So we're going to go ahead. It's dotted line. There we go. There we go. All right, so greater than, and we're talking about, I guess the better way of kind of thinking about it is you're focusing on that y that's there. Now, I'm still going to just test it out here. Plug in 0 for x. Oh, I can't plug in because it's right on the line. So I'm going to grab the order pair 1, 1. So is 1 greater than negative 3 times 1? Is 1 greater than negative 3? Yeah, it is. So we're shading over here right now. Okay. I'm not going to go crazy with it because, again, I'm going to have the overlap. Let's grab the next one here. Let's go red. So less than negative 2x minus 1. Go down to my negative 1, and my slope is 2. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. It's a dotted line as well. I don't know. I always feel the need to sound effects when I'm doing dotted or solid lines there. Okay. Again, this time, went through a negative 1 down there. So I can test out 0, 0. So is 0 less than, well, 2 times 0 is 0. Is 0 less than negative 1? No, it's not. So no, I don't want it. So again, I'm going to go to the other side, which is actually going to put me over here. All right. So again, you can see the less than, it's below it. So again, focusing on the y's of it. Now, right now, this is where you kind of want to take like just like a stock in it and be like, wait, where's my answer right now? And kind of visually, you want to realize, okay, it's just right over here. This is where it's at. I've got one more, x is greater than negative 4. Okay, it's just x. So that means it's a vertical line going through negative 4. Vertical line going through negative 4, and it's dotted. So let's change colors one more time. And I want where numbers are greater than. So that's going to be everything over here. Now, again, people, it's messy. So this is where, that's why you want to focus in on an area. And then I did there. So yeah, my answer ends up turning out to be everything that's there. So no matter what ordered pair I grab in there, all right, that's what my answer is. So main thing here is focus on those. Is it dotted or is it solid? And then again, if you're comfortable, because we're in that slope intercept form, looking at that y above and below, you can do that. Otherwise, you're still testing it out. Again, I encourage you to still kind of test a little bit until you get really confident with it, because I'll be honest, sometimes I look at it and I'm like, I'm not too sure. So testing it out is a good thing here. But yeah, that's what we're after here. The ability to graph, dotted or solid, and then you're shading, and then you just want to know where the overlap is at. All right. There you go. We'll see you later.